Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and today we are going to look at how to write a problem solving and modelling task. This is aimed at students in Queensland studying mathematics in high school. And we're going to focus in this video on our first part of our instrument specific marking guide, the ISMG, on how to solve using accurate use of complex procedures. So in this video, we'll talk about what accurate means, we'll talk about what complex versus simple procedures are, we'll look at what a valid and reasonable solution is, and then talk about what's coming up next in this series. So let's look firstly at our ISMG, the Instrument Specific Marking Guide. You can see that that very top box worth 6 to 7 marks is the place we want to hit to get maximum results for our PSMT. And in fact, we want to be able to achieve accurate use of complex procedures. That's our first start point. So we want to know what's the difference between achieving it in this box versus the next box down, which is just use of complex procedures. So what are we looking for in terms of accuracy? That's the only difference between those two lines. So let's have a look. Accurate, according to the QCAA's definitions in their syllabus, is precise and exact, to the point, consistent, using a rule model conventional facts, free from error and defect, meticulous and correct in all details. So that's a very good description there. So the first thing that you can do to achieve accuracy in your assignment is to check your work. A lot of times students are rushed for time, possibly because they've started the night before and they don't get time to actually check their work. It's a really good idea to do that. Firstly, you need to ask, does your answer make sense? Is it what you're expecting? So it's always a good idea before you start solving, when you're writing your observations and assumptions, to have a bit of a think about what you're actually expecting to find as a result. For example, if you're doing an assignment on bivariate data analysis and you're comparing somebody's length of their arm to their length of their leg, you'd kind of expecting a strong correlation because most people's arms and legs do grow in some proportion. So if you found out that your correlation was very small, for example, you'd be asking yourself, does it make sense? And you'd be saying, probably not. So the first step you would actually do is go and check all of your calculations first, if it's not what you're expecting. There are situations where you would find that your answer doesn't make sense and you have checked your work and it is correct. So then you need to actually review those observations and assumptions and see if there is something faulty with one of those. Also, a good way to check your work is to check those manual calculations that you've completed using a Microsoft Excel spreadsheet or Sheets if you're using an Apple device. Make sure also that when you have presented your working in your assignment that you've shown all your steps of working. Don't skip any. It's very hard for your teacher to check the accuracy of your work if you've skipped a bunch of steps. They don't know exactly where you've gone wrong and they can't award you follow-through marks if they can't find where you went wrong. Another good way to check your work is to start at the end and see if you can work backwards to the beginning. This works particularly well, for example, if solving equations. If you were to find that, for example, in an equation that x was equal to 3, can you then substitute x equals 3 back into the beginning of the equation and get the right answer? Is there another method that you could potentially use to check your work? Have a think about that. There's different strategies sometimes. For example, if you're using trigonometry or you're using Pythagoras' theorem, there can be sometimes multiple triangles within one situation where you can check your answer in a different way. And also, there are many online calculators available for you to check your solution with. If you're doing an assignment on matrices, there's online matrix calculators. If you're doing an assignment on for example, trigonometry or unit circle, there are online calculators for pretty much everything you can think of. So check your work using one of those. Okay, so we've covered that. Now let's have a talk about what the difference is between a complex procedure and a simple procedure. You can see in the first two marking sections on the ISMG that to actually hit a mark in the range of 4 to 7, you need to have shown complex procedures. And if your procedures aren't complex, you're going to jump straight down to that third box in the 2 to 3 range, which we definitely want to avoid. So students often wonder, well, what's the difference? How do I know if something's complex or if it's simple? Well, according to the QCAA's vocabulary on their syllabus, complex means it's composed of many different and interconnected parts. It's compound, it's composite, characterized by an involved combination of parts. So that implies that there are multiple steps involved. Perhaps you're solving one thing to then solve something else. So it doesn't always mean that complex doesn't always mean it's hard. It might mean that there are many parts to the problem. It can also mean that it's hard. You'll notice the next part of the definition is complicated or intricate. So be aware it could be the more difficult content that you've learnt this term or this semester that you actually need to demonstrate you can do accurately. Simple, on the other hand, is something that's very easy to understand, not complex or complicated, it's not elaborate. There's basically one or a couple of steps, very few elements to the problem. So if you've solved something and you thought, wow, that was super easy, there's a good chance you're not on the right track. Okay, so what is complex and what is simple will also often depend on what grade you're in at school and what the syllabus is for the maths strand you are studying. Now, a lot of students aren't all over the syllabus. They tend to rely on whatever the teacher tells them to study from the textbook, and they don't look a lot more deeply than that. However, it is a good idea to look at your textbook, at the chapter. At the very beginning of the chapter, there is often a summary of all of the different content you're going to cover in the chapter, and also a good idea to look at the course outline that your teacher's given you. And you can actually go to the syllabus online. If, for example, you are in Queensland and you are studying senior mathematics, you can actually Google for the QCAA syllabus for essential maths or general maths or math methods and so on. If you're a junior from grade 7 to 10, you can actually jump onto the Australian Curriculum website, ACARA, ACARA, and you can actually look on there and find out what you're expected to know at your year level. So have a look at what content you've covered in class. If you've missed lessons, find out what you missed and what you're expected to cover. Sometimes a PSMT is given out at the beginning of a unit, and then it's kind of hard to know what you're expected to know. So you're expected to be learning as you're writing your PSMT. So it's a good idea to look ahead at what your teacher's planning on teaching, because all of that content is considered to be the content you need to be demonstrating in your PSMT. Have a think about how the level of your difficulty of your subject changed from last year. I'm going to show you in a moment with some different topics how it changes from year to year. Now, if you're in grade 11 and you're only working at a year 9 level from the year 9 sort of content that you learned in the past, chances are you're not showing complex content because there's 2 extra years in there that you're expected to have demonstrated new skills on. You aren't expected to demonstrate knowledge outside your syllabus, however, and this is something that a lot of students do have a little bit of a mind panic about. They think that they're expected, if they're in general maths, to be able to demonstrate the work in math methods if there's application, particularly if you're a student who's come from math methods and moved to general maths. You still have your head thinking, oh, maybe I need to demonstrate this at a math methods level. The answer is no, you need to demonstrate it at the level of the syllabus that you are currently studying. You are expected to demonstrate all of the skills that you're taught. So consider all of the skills you're taught and how they apply to your task. So it's really important that you read your task sheet thoroughly and don't ignore any of the instructions. Read that flow chart at the back as well. Sometimes there are little extra clues in there as to what you need to do to solve accurately. So let's look at some syllabuses now. This one's a topic of linear equations, and if I was in grade 9, I'd be expected to solve using linear equations and worded problems. But if I was in grade 10, I'm expected, as part of the new content I've learned, to be able to solve simultaneous equations using elimination and substitution methods. So if I'm doing my assignment and only demonstrating that I can solve equations with one variable and I don't actually consider other variables in my solution, chances are I'm only showing simple procedures. However, if I moved into year 11 methods now, I'm actually expected to solve polynomial equations, and in year 11 specialist, I'm expected to solve using matrices. So if I'm actually just reverting back to the year 10 work that I've done in grade 11, then I'm actually going to only get marks for simple procedures. I've got to be able to demonstrate the extra content that I've learned for my year level. Let's think about statistics. If I was in grade 8, I'm expected to find the mean, median, mode, range, and the interquartile range. But if I was doing year 10 extension prep methods, I'm also expected to calculate and interpret the standard deviation, and that's the same in year 11 general maths using technology. However, once I move into year 12 general maths, I'm actually expected now to use the standard deviation to develop a least squared regression line. So if I'm in year 12 and I'm writing my PSMT on statistics and all I demonstrate is mean, median, mode, interquartile range, and I forget standard deviation and ignore it completely, and I don't even use it to develop a least squared regression line, then there's a really good chance that I have missed the complex content and I go straight down to simple content. In Year 11 math methods, I'm expected to also use and calculate the variance. So if I ignore the variance, once again, I'm only demonstrating Year 10 level of understanding, simple procedures versus complex procedures. Let's consider bivariate data analysis. If you're in grade 10, you'll have drawn a scatter plot. You'll have worked out the line of best fit on your scatter plot by determining that using your own judgment, and then you'll calculate the line of best fits equation using y equals mx plus c by finding 2 points on the line, calculating the gradient, and then the y-intercept using algebra. However, if I'm in Year 12 maths, I'm expected to go a long way beyond. I'm actually expected to come up with the least squared regression line, not just the line of best fit. And I'm not expected to use y equals mx plus c because that's grade 10 content. So in Year 11 and 12, that's considered to be simple content. So I actually need to then go beyond and calculate r and r squared. I need to find the least squared regression equation using the formulas from your formula sheet, and then find the residual plot. I often find students in Year 12 general maths forget to do their residual plot for their assignment, and that is considered to be the most complex content of the topic. So if you don't draw a residual plot at all in your Year 12 PSMT, goodbye to the complex content mark. You'll actually get simple procedures. So make sure you know how to do a residual plot. And as I previously mentioned, often when you start your PSMT, you won't have actually learned how to do residual plots yet because that content is still being taught. So don't forget, it's the complex content of your syllabus. If I was studying trigonometry, for example, in Year 9, I'm using basic trig ratios, SOHCAHTOA, sine, cos, tan, to find sides in and angles in right-angled triangles. But when I move into Year 11 general maths, I'm now using the sine and the cosine rule. That becomes my complex content. And I'm finding sides and angles in non-right-angled triangles. If I'm in methods, I'm actually doing unit circle, exact trig values, and graphing those trigonometric functions. And in Year 12 methods, using those functions to produce calculus. So if I'm in Year 11 and 12 in methods with a PSMT on trigonometry and I'm stuck on SOHCAHTOA back in the olden days, I'm not going to demonstrate complex content. With procedures, it's always a good idea to ask your teacher what their expectations on working are. Every teacher has a different expectation, and it's a good idea to know what they're expecting, not just what Mrs. McClutchie on her videos is expecting. So at minimum, I would say that you at least need to do a sample calculation in the body that is fully worked with no steps skipped. So for example, if you're doing Year 12 bivariate data analysis, you're going to develop the equation of the least squared regression line using algebra, showing all the steps of your working. You're not just going to write the equation there and think it's all great. Even though technology could work that out for you, you'll need to do that algebraically, fully worked with no steps. If there is other techniques that you need to demonstrate, for example, you may have needed to calculate Pearson's correlation coefficient, you're going to do that showing all the steps. Okay, any other calculations that are repeated based off your sample calculation, you can actually put these in the appendix and reference it in the body. Now, what I mean by that is, let's say, for example, you've got 5 data sets and you need to find the mean, median, mode, and standard deviation of all 5 data sets so that you can make comparisons. Well, you're not going to do all 5 data sets in the body because that will take up pages and pages of work. You might just show all of those calculations for one data set, and you'll have as your heading sample calculations, and then for the other 4 data sets, you'll put the results in the appendix. But it's really important that you reference in the body that the other 4 data sets can be found in Appendix C or Appendix 5. It's not good enough to just put them in the appendix and expect your teacher will find them there. Otherwise, you won't get full marks for your complex procedures. You should be guided by the QCAA exemplars and other exemplars that your school has provided for you. They often show what your teacher's expectation is. You should also consider how you've presented your work. It's a really good idea to become familiar with using Equation Editor in Microsoft Word. If you're going to handwrite and scan all of your calculations in, you may end up losing marks from your teacher because there's no way they can actually check your work against other students using Turnitin or another plagiarism detector. So using Equation Editor makes sure that you are able to be checked. Also, consider using setups of tables inside of Microsoft Word so that you're not having wasted white space. What I mean by that is often if you've got quite a long calculation, it'll extend down the left-hand side of the page with all of your equal signs lined up, but then you'll have all this white space on the right-hand side of your page, and it's kind of wasted space. And we all know that we're working to page limits here. So if you were to put your working inside a table, you'd be able to start down the left-hand side and then move along to the right-hand side. It's always a good idea as well to use some language to explain your working. That doesn't mean you need to write a book or a paragraph, but for every time you change your calculations into a different direction, there should be some words to explain what you're doing. So for example, if you're using Pythagoras' theorem in 3 dimensions, you might have 2 triangles that you're actually working with. So you would have a sentence that would say, using triangle A, and then you would do your working for that, and then you would have another sentence that would say using triangle B and your second set of working for that. So every time your calculations change direction, where you use one number from this calculation to move into a different direction to calculate something else, always use a few words to explain what you're doing. Here is an example of a great sample calculation. Firstly, you can see that it has an appropriate subheading, finding the equation of the line of best fit. Secondly, you can see that there's a brief explanation of what is being calculated. We've got a formula that we're using, and what are we substituting into that formula. You'll notice then that equation editor has been used, and it's been used very effectively. And you can see that every step of working has been used as well. No steps are skipped, and there is a reference at the end to the location of all of the additional working. Obviously, there are other equations of lines of best fit in this particular assignment that need to be developed, and they're developed in the back of the assignment. Here is another way that you can actually set up your calculations if you've got lots of calculations in a table. Notice again there is a reference to the location of all the additional working in Appendix 2 for data sets B and C, so it's very precise as to what's been calculated and where it is. You'll notice this table uses that white space very effectively. We've got some use of the divisions of the different rows and columns that enable you to see all the steps. Here is another example that's a great one, which uses words to explain the change in the working procedures. We've gone from calculating the area and moved on to calculating perimeter. So those little subheadings there tell you when the working has changed directions. Here's an example that is not so crash hot. I don't know if you can notice, but you have no idea what's been calculated. What on earth is PA? I happen to know from the context of this assignment that it's physical activity, but you need to remember part of your communication grade explains that you were able to read this independently of the task sheet. So if PA has never been defined as physical activity in the assignment, then that's really unclear. Also, what on earth is being calculated? Is it an average? Is it a median? There's no formula that actually states what's being calculated. So you really need some information there. And also, the rest are in the appendix. The rest of what? Well, it just so happened that this student only calculated the mean of the 2 data points, but they also did a number of other calculations, median, mode, mean, standard deviation, and every one of those calculations was in the appendix as well. They actually need to provide a sample of every one of those different types of calculations. Here is also another example where there are no complex procedures in the body. They actually didn't do any calculation of the line of best fits equation, which was the complex procedures for this Year 10 assignment. This is another one from grade 10 as well. You'll notice that the formula is not appropriate for the year level. By the time you get to grade 10, when you're calculating the mean, you're no longer using a word formula. You're using a formula using algebraic variables. So it's important you use the formulas that are appropriate for your year level to demonstrate that you are working at complex standards. Also, you'll notice that this is an incomplete formula. The median actually uses the n+1/2 number. TH should be at the end of that. And we use that to find the data set. Also, you'll notice that this is actually just a list of formula. There actually are no calculations here whatsoever. They aren't even sample calculations. So you actually need to do some substitution of some real numbers and demonstrate the use of the formulas, not just state formulas as part of your sample calculations. Let's talk now about the difference between a valid and a reasonable solution. You'll notice we want a valid solution because that sits in the very top mark range of 6 to 7, whereas a reasonable solution sits in the 4 to 5 mark range. So the key difference here is accuracy. In fact, if we go back, the first one is accurate use of complex procedures, and the next one is not accurate use, it's just use of complex procedures. So that key difference is how accurate they are. The minute you start making mistakes and errors in your calculations, you're going to actually drop down to the next box because your solution's not accurate. And because it's not accurate, it's not valid. So our definition from the QCAA is that valid means sound, well-founded, authoritative. Reasonable means sound judgment, fair and sensible. They both sound like they're pretty good solutions, and that's the key too. Valid and reasonable are pretty good solutions. However, valid is more of a good solution because it's accurate. So here's an example here. Let's find the optimal size of a can of soft drink such that the amount of metal used is minimised. A student may try a range of radius and height combinations to find the choice with the lowest surface area using the formula. This is part of the task sheet. So let's say that we did all our working and we found that the correct combination to use was 10 centimetres with a 10 centimetre height for our can of soft drink. And that is the only possible solution we could have found. However, one of our students has made a mistake in their working and they found a 9 centimetre radius and a 10 centimetre height. Well, in real life, it's not going to make a massive amount of difference. However, it's important to note that it's not completely accurate. So that's actually could make a business, if a business was to rely on that information, a great loss of money. So it would not actually be an accurate use of the complex procedures. It would just be the complex procedures was used, but just not accurately. So that would drop you down to the next box. And it wouldn't be valid because it wouldn't be the lowest surface area that could be used in the context of that situation. So therefore it wouldn't be correct. And if a business did have to rely on that decision, it could be quite costly in the long term for that business to rely on that. The solution would be reasonable though, because you would expect a can to find the size, and it's only out by a centimetre. You would expect to find a can in that size. However, it's not reasonable for the context we've given because we said it had to be 10 by 10. Now, we've also got the situation where somebody has used some complex procedures, may not have done it accurately, versus a student who has used simple procedures. Now, if you're using a simple procedure and you haven't used the complex procedures you're expected to use for your syllabus, you're actually not going to come up with a valid or a reasonable solution. You'll make some progress, but you won't really have a solution that's suitable. So let's say somebody explored an unrealistic range and they found the optimum size of the can was 1 centimetre by 1 centimetre. Well, it would definitely have the lowest surface area. However, it's not a valid solution. It's not a reasonable solution. It may even be error-free, but if they didn't use the right procedures and they didn't have a reasonable solution, it's the wrong domain. So really, it's not use of complex procedures either, but they made some progress. It's just not a reasonable or valid solution. It's just progress towards a solution. So in that case, they would hit that box down there. Let's talk a little bit about inappropriate procedures. So we're going to focus on technology in a future video, but sometimes students don't even use complex or simple procedures. They use the wrong procedure altogether, and that means that they're not got a valid solution, they don't have a reasonable solution. In fact, they haven't made any real progress. So this would be a case, for example, where a student decided to work out the surface area of a rectangular prism. It's a completely wrong shape, and so therefore it's not even going to be progress towards a solution because you're supposed to be finding the surface area of a cylinder. Same as if a student went and found volume and they've worked on probably what you would consider to be a simple or a complex procedure depending on their unit level, but it's not the correct procedure. It's an inappropriate use of a procedure. Okay, so let's have a quick talk now about what's coming up in our next videos. The next video is going to focus on the discerning application of math concepts and techniques. So that's the second box in our ISMG. If we just go back to that one there, you can see that's that second box down. So that's our next video. Our next video after that will look at an accurate and appropriate use of technology, and then we'll have some videos on evaluation and communication. If you found this video helpful, please tell a teacher or a friend, like and subscribe to the channel, hit that notifications button, and follow us on Facebook and Instagram. There's lots of ways for you to stay in touch. It's always good to share the love with other people, so sharing this video will help your friends and family members find success as well. I'd like to say thanks so much to you who, if you're an ongoing viewer of the channel, welcome back. And if you've got any questions about anything you heard in this video, then you can direct message me on Facebook or Instagram or via mcclutchymaths@yahoo.com. A lot of students do write to me and ask me to check their PSMTs for them and provide feedback. Unfortunately, I can't do that. That would be a breach of teaching ethics. So please don't send me your PSMT and ask me to do it for you or help you write it. I am happy to look at, for example, a single observation or a single assumption and tell you if that, for example, is documented or undocumented, but I generally don't give any support for solved questions, unfortunately. My best advice is ask your teacher. Well, once again, thank you so much for joining me. I do look forward to seeing you in our next video. You've been watching McClutchy Maths and I'm Natalie McClutchy. Have a wonderful day.